Hello students, today we start the part of the chapter that will be graphical representation of motion. First we will read about the distance time graph. That will be your how you will draw the distance time graph of the different position of the object and what are the nature of the graphs. First come to distance time graph. The change in the position of a body with time can be represented on the distance time graph. In this graph, distance is taken in the y-axis and time is taken in the x-axis. In your mind, it will be there why it is taken in x-axis. Mostly we are using the independent quantity in the x-axis. As from the distance and time is the independent quantity. So, time is taken in x-axis, that will be horizontal axis, and distance is taken in y-axis, that will be in vertical axis. Here you see there will be one table I have made here. The time is increasing gradually where the distance covered by the object is not changed. Means the position of the object not change with respect to time. Then when we plot all this, then we have got the line parallel to time axis. That means for the object is at rest, which is from the definition you have got, there will be no change with respect to time. It is at rest. So distance time graph is parallel to time axis. So distance time graph is parallel with respect to time axis or x-axis for the object is at rest. Now come for the when the object is in motion. That means there will be two types of motion you have read. One is uniform motion, another is non-uniform motion. First come to uniform motion. That will be the x-axis time axis and distance is your y-axis. Here time has taken in the am and also distance in kilometer. Here the plotting we have got that the line is straight line passes through the origin. Means from the origin, then it is inclined to time axis, and it is a straight line passes through origin and it is inclined to time axis, and it is for uniform motion. How you will decide it will be uniform motion? Because it covers equal distances in equal interval of time. Time is 15 minutes and here also 10 kilometer. 15 minutes, 10 kilometer. From this graph we can find out the velocity of the object at any instant. The velocity is your displacement by time, or you take the speed, then it will be distance by time. Then from the graph we can find out the velocity. That means any position you can take, any position you take, then you find out the parallel line with respect to the distance and parallel line with respect to time. Then there will be the formula is s2 minus s1 by t2 minus t1, means the final position of the object, then the initial position of the object, then final time, then initial time. Then you just divide and find out. From the graph we can find out the speed of the object at any instant of the time. That is for uniform motion. Then come for the non-uniform motion. That will be your distance diagram from non-uniform motion is non-linear, as the distance covered by the object is non-uniform. It is not equal with respect to time. So you see everywhere you have taken 5 seconds, but the distance covered by the object is not similar or uniform in this way. So it will be your non-uniform motion. That will be a non-linear, or we can tell easily it will be your a curve. Thank you.